All right, welcome to our next video in the series on programming in Java. Our learning target today is parameters and returns. So at this point in watching these videos and learning Java, we have started going through the trouble of declaring variables, writing multiple methods, and the problem we're trying to solve today is what is the best way to communicate information between methods. So let's talk about what our little learning targets are. Whoa. Okay. So let's talk about the definition of parameters and return types. Let's talk. Oh, these should definitely be comments. Duh. So we're going to talk about parameters and return types. We're going to talk about the difference between formal versus actual parameters. We're going to talk about the difference between, we're going to talk about something called pass by value. What does it mean when we pass a value to another method? Is the change temporary? Is it permanent? We will define the terms method signature and overloading. We're going to introduce what it means to return a value. And we're going to talk about words like void, and we're going to discuss how to save the results of a method. So could be a longer one. Buckle up. Here we go. All right. So far in our programs, we have been designing a program whose job it is to maybe print an image. That image will scale and get bigger or smaller. We have projects like Space Needle. We have projects like Book Printer, Pine Tree. And what we did was to declare a class constant at the start of our code. We would declare this variable outside of our methods because this helped us with scope. Remember, scope means the place where something is visible. So if I declare a variable inside of my main method, well, only the main method can use it. And only things after I've declared the variable can use it. If I have another method, another helper method, outside the main method, it can't use int x. If instead I declare this variable out here, well, then it's visible by everybody, and everyone can use it. This is said to have global scope, meaning everybody can see it. And sometimes when we declare a variable out here, we feel that it's important that it not be able to be changed, and we make it something called a constant. And the way to do that is, so we would, when we declare a variable globally that's going to be used by a static method, like the main method, and we haven't really gotten into what it means to be static yet, but just know that any method that has static right here is a static method. Well, any global variable used by a static method must also be static. So this is now a more appropriate use of a global variable. But if I also wanted to make it so that this couldn't be changed, I would say final. I think this might be reviewed in another video, but the idea is it can now no longer be changed. We would change its name to be all capitals, and now anybody can use it, and x can never be reassigned. Okay. This is how we have passed information to and from methods up until this point. But there's got to be a better way. If you can imagine there needing to be 5, 10 more variables that need to go between values, having a long list of global variables up here is going to be messy, and it's going to open the door for other opportunities for us to make errors. So a good rule of thumb is to only provide the information to the method that it needs. Don't overkill providing information. So enter into parameters. What is a parameter? Well, a parameter is a way of giving information to a method when it first executes. For example, I might make a method called public static void square, and square takes as a parameter, I'm going to say int x. And the job of square is going to be to print out the square value of whatever I'm passed. So I'm going to say system.out.println x times x. And that compiled, I go to run it, square, let me think, what do I want to get the square of? Let's say square 5. I'm going to go ahead and run my code, and sure enough, it gives me 25. Now, you're probably thinking to yourself, gosh, you probably could have just said 5 times 5 right here, but I'm just illustrating the basics of how a parameter works. So let's talk about what we're looking at. First, this is the parameter right here. This is considered to be the formal parameter. It's going to look a lot like defining a new variable. We say that when we create a variable, it needs to be declared, it needs to be assigned, and then it can be used. We're allowed to declare a variable, which means you just provide its type and its identifier without assigning anything first. That's okay. And so this looks like a new declared variable. And what's interesting is the parameter is just saying, I'm going to be given a piece of information. I'm going to be given one piece of information. That one piece of information has to be an int. And whatever it is, whether it was a literal value like this, or maybe it's a variable before, once it gets to me here, I'm going to call it by its parameter name. This thing is now going to be known as x. Whatever is passed to me is now known as x. I will take that information and I will use it right here, giving me x times x. It is in fact possible to have multiple parameters. Let's say I wanted to do x and y, and I'm going to change the idea from this method from being the square to multiplication. Well, I can now say x times y. I go to compile. Ooh, Java's upset because it says, hey, well, first of all, there's no longer a method called square. Now it's called molt. But in addition, molt says, well, you can't run unless you provide me the correct parameters. So I need two parameters, both of them ints. If you can't give me that, then I won't run. So we'll do a 5 and a 3. We compile, we run, and we see this is how to provide multiple parameters. So the idea is when I make my method, I kind of give a blueprint for how it's going to work, and then some other method will likely call this with the actual parameter. So at the time I write the method, I don't know what value is going to be used. When I'm ready to call that method, I'm going to go ahead and hand it an actual parameter like 5 and 3. These parameters can be anything. They can be ints, doubles, strings. You can do a whole bunch of stuff. There's another example that we can give called, how about repeat string? And I'm going to say string word. It's often useful, just like when you're defining your variables, to give them useful names. I'm going to call this string word, and I'm going to call this int num for number of times to be repeated. And what I want to do is I want to print out a word that number of times. So if you saw the for loops video, we know how to build a for loop so we can repeat a task. I'm going to say for int I equals 0, I less than num. And here I am using my parameter, not perimeter, my old geometry background got me right there. I less than num means that go until you've reached whatever the number was passed in the parameter. Then we're going to say I plus plus, and we can just print out the word that number of times. We'll print out the word. Nice. Now again, molt is mad because it says, well, hang on, it's no longer called molt, and if I call repeat string, well, you're still not giving me the right type. I need a string and an int. And so we can fix that. We'll say bird because last I heard the bird was the word. And so we go to execute it, and there it is. By calling repeat string bird3, we passed the string literal bird and the int 3 down, and they were able to use that to execute it. And what's nifty about this is this allows for an incredible amount of code reuse, right? So if I had multiple words I need to repeat multiple times, rather than making an individual for loop for each of those, because I see there's a common task, I could just declare, execute another repeat string method. Maybe I'll say hello world, and I'll say it, geez, I don't know, how about 50 times? Let's get crazy. All right, here we go. Boom, there it is, 50 hello worlds. All right, so that's what it means to pass a parameter. We have, remember, the formal parameter is just type and identifier. We don't actually say the value that's going to be passed. And then when we're doing the actual parameter, we don't need to specify the type. I didn't have to say string bird. We just pass it a string, and it'll know what to do with it. All right, so we've covered parameters. We're going to get to return types. Formal versus actual we've discussed. Let's make another method just to prove a point. Passing primitives. And I'm going to take an int, we'll call this guy x. And what I want to do is I'm going to show that when we pass something to a method using a parameter, that we should be cautious because the changes that we make down here are temporary. The reason for this is because primitive values like int and char and double are considered something called pass by value, which means when we pass it as a parameter, we send a copy. We actually don't get the original thing. So what does that mean? Okay, so let's say int x arrives here, and I say, you know what, x, you need to be 1 larger, and then I'm going to print you out. System.out.println x. We'll go ahead and get x to print out. Okay. And then I need to call passing primitives, my method. So I'm actually going to go ahead and scoot away these old methods so they don't give me any trouble. Let's call it passing. Well, actually, what I need to do first is I'm going to make another variable called int y, set it equal to 5, and then I'm going to go ahead and pass y down to passing primitives. So let's see here, passing primitives. Oh man, did I spell primitives wrong? We're just going to go with it now, primitives. Passing primitives, we're going to send y down. And then I'm going to print y out up here. Now I'm actually going to concatenate with that y an exclamation point so you can see which print statement is which, because sometimes it's hard to know which is which. So I go to run it, watch what happens. So first, let's look at who processed first. The one with the exclamation point did not process, which is unusual because you would think that it being in the main method maybe it gets priority. But remember how the flow of control works. If I call a method passing this parameter, I have to go resolve that before I can finish this particular statement. So we declare y as 5, we pass it as a parameter. Now, even though it went by the name y up here, by the time the value 5 makes it down here, it's going to go by the name x. We take x, we increase it, we print that out, and that's what gave us 6. So you might think, okay, I passed y down and it got increased. Shouldn't it also be 6 right here? And the answer is it's not. The reason is when you send a primitive value down to a method, that method just gets a copy. So any changes you make to some variable down here are going to be temporary. That's what pass by value means. All right, so let's talk about what method signature and method overloading are. Let's say, I'm going to go ahead and just make a little space. Let's say I wanted to make a really basic method, something pretty simple that you would not actually make a method for this, you would just do the math. But I'm going to say public static void add. And it's just going to take an int a and an int b. And its job is going to be to print out the sum of a and b. All right, pretty simple. So if I go to print out, if I call add on 10 and 37 and 32, I go to run this, we should get 42. Okay, no problem. But then I might think to myself, well, shoot, maybe I want to add just not 2 things together. Maybe I want to add 3 things together. Well, you might think that you have to then come up with a slightly similar name like add 3. But here's the good news. Java says we're allowed to declare multiple methods that have the same name as long as their parameters are different. So we can say public static void add, I'm going to go int a, int b, int c. And this time we will go ahead and print out a plus b, and we will just add in there c. Now here's the cool thing. Identifiers are what key Java into what method you're referring to or what variable you're referring to. So you might be worried, oh shoot, I'm using add both times. Java is not going to know what to do. Well, it turns out that add is only part of the method signature. The method signature is made up of the name of the method and the parameters. So when I called add right here, Java looked at not just the name that I used, but also the quantity and type of parameters I used. And that's how it figured out how to use this first method right here. So I can still compile and run, and we're good to go. I could say, you know what, I would like to add 6 and 7 and 8. Compile, run it, and away we go. 6 and 7 and 8 makes 21. So what we're doing here is something called, this is an example of overloading. So overloading means multiple methods with the, same name, different parameters. And we will see that there are methods provided to us by Java that are overloaded. At this point, we haven't seen the math or string class, so it's hard to come up with an example. But in the next video, you will see some of Java's inherent methods that are overloaded. Multiple methods, same name, but they varied up the parameters to make it more usable. All right, so that's overloading. So the next thing we're going to talk about is, let's see what I did. Returning a value. So you might be wondering to yourself, okay, well, printing is all fine and good, but what if I needed the result of that sum up in my code? I wanted to add these things together, and then I needed to save that value. Well, printing it didn't do that for me at all. Well, here enters return values. Every method that we've written up until this point included the word void. And what void means is return nothing, meaning that this method has no responsibility, nothing it needs to give back when it's done. This is often true. You will continue to write methods that have the void keyword because they return nothing. But it's going to be more often the case that you want a method that produces something for you to use later. So for example, I could change this void to say, you know what, instead of returning nothing, would you return an int? And when I go to compile now, Java is going to balk because it says, look, you promised me you were going to give me an int. And so Java now won't compile until I give it an int to return. So this technically compiles, but the problem is I don't know that the numbers I'm being passed are going to add to 5. I need to actually use those. So we say, using the return keyword, return A plus B, and there it is. Now our add method actually returns us a value, which is useful. But watch what happens when I go to run my code. I go to run it. Oh, the 42 disappeared. And the reason is because we need to be careful to save the results of our parameter returns. Meaning that I went through the trouble of calling a method, using 2 particular parameters, passing it down. They performed the math I needed. The value was returned here. It was like all these characters were replaced by the number 42, and then nothing happened with it. One of my students jokingly called this a dead call one year, which maybe we're all like really into The Walking Dead or something, but I love that. I think that makes sense. It's a dead call. You used a method, returned something, did nothing with it. So the solution here is let's declare a variable and save the result of that method so we can use it. So I go to run it again. Oh, it still doesn't appear because, oh yeah, that's right. Well, now that I've saved it, I can go ahead. Oh, let's remember how to print. I can go ahead and print it. And away we go. And for those who are wondering, you could just put add 1032. You could just put it between the parentheses right here. That would also work. I'm a fan of expanding lines of code. There's a lot of ways that we can combine 2, 3, 4 multiple lines of code into one statement. That feels fancy. It's fun. It's an interesting intellectual challenge. But while you're a new Java programmer, try to perform one function at a time at any given line of code so that you don't overwhelm yourself. It's usually a good rule. All right, so this is how to return a value. This can be anything. This could be int, double, boolean, char. It could be string. Later in your studies of Java, You might choose to define your own class, and that's the type that has to be returned. So that's what it means to return. All right, we've talked about void, saving the results. I wanted to give you an example for those of you that are stuck on this particular homework problem. What does the half the fun method do? Well, let's check it out. Half the fun says take an int as a parameter. We're going to call that int number. Whatever that number is, chop it in half. And then start me out a for loop. Start the count out at 0. Count up to and include that number. And increment by 1. And then print out your index as you go. So I'm going to go ahead and I'm going to delete my current stuff so we could see this work. There we go. Oh, let's get rid of our class constant. All right, so if I call half the fun on, I'll call it on 5. Let's see if I can predict before I execute it what it's going to do. All right, so the formal parameter is here. Int number is a formal parameter. The actual parameter is here. 5 is the actual value being sent. So 5 comes down here. This value begins to go by the name number. And we say, hey, number, whatever you were, chop yourself in half. That's what you are now. Barbaric. But here's the deal. Number was 5. 5 divided by 2. Let's remember our rules of integer division. If I'm doing math on 2 ints, I must produce an int when I'm done. And so I can't say 2.5 here, much as I might like to. 5 divided by 2, according to Java's integer math, is 2, because it goes in 2 times. All right, so my number is 2. So I can imagine that instead of seeing number right here, I see 2. So I'm going to say int count equals 0, count less than or equal to 2, count plus plus. So it seems like I'm going to get a count of 0, then we'll go up by 1, a count of 1, then we'll go up by 1, a count of 2. 2 is still less than or equal to 2, so that clears. But then when we say count is 3, 3 is not less than or equal to 2, so it should fail. So if we are getting this right, we should see 0, 1, 2. Ta-da! And that is an example of how parameters work. All right, thanks for watching.